Paano nga ba nangyayari yung movement ng mga plates sa ilalim ng Earth's surface? At paano nabubuo yung folds and faults? At ano ang nagiging result nitong formation ng fold and faults? At paano rin nabubuo yung mga rock layers? Paano nga ba? Pero kung gusto mong matutunan yan, aralin yan, panoorin mo ang video ito. Happy learning! Work from home si Sir Fox. Good day everyone! Kumusta? Welcome to Sir Fox Learning Channel again. For today's video, pag-aaralan po natin ang movements ng plates, formation of folds and faults, and formation of rock layers. At kung bago ka sa channel na ito, huwag mong kalimutang mag-subscribe at i-hit ang notification bell on para maging updated ka sa mga susunod ko pong video lesson. Sana po nagustuhan nyo po ang presentation na ito. Happy learning everyone!
Okay, ang pag-uusapan niya po natin sa video ito ay patungkol po sa movement of plates and formation of folds and faults. Our learning target for this week number 5, is to identify the 3 types of plate movements from short excerpt, expound 3 types of plate movements based on plate tectonics theory using an illustration, and cite specific examples of landforms as outcomes of plate movements. Speaking of plate tectonics, John Wilson in 1908, he validated Wegener's theory of the plate tectonics. Speaking of tectonism, the isostasy, which is identified as the cause for differences in the height of mountain ranges, so superficial processes like catastrophic global floods had curved our ocean basins and deposited mountains of gravel, not enough to explain large-scale or regional or global movements and the formation of Earth's crust. What driving mechanism curves out the whole Earth's surface? What driving mechanism curves or carves out the whole Earth's surface? Alfred Wegener, he noticed that the shape of the continents much of like pieces of global jigsaw puzzle. So do you know what is a jigsaw puzzle? Alfred Wegener, he noticed that the shape of the continents match up with this jigsaw puzzle. According to him, all continents were once part of a single supercontinent, which he called it Pangaea, and then parts of which drifted apart to form the smaller modern continent. So drifted apart from a big one, a single supercontinent, it was drifted apart to smaller modern one continents. Therefore, there was a theory or continental drift theory. These are some of the hypotheses of continental drift theory. There was an anti-drift scientist who viewed that continents are stationary landforms that could rise and fall but not drift sideways. There was also one scientist that believes that Earth was cooling from an older semi-molten state, so it must be shrinking rather. Earth hypothesis. continents were moving together rather than drifting apart. So shrinking rather than drifting. And some believe that Earth's crust shrunk into less space. Flat rock layers in ocean basins would have been squeezed and folded between the continents as observed in the Alps. Excuse me po. With this movement of crustal plates through convection currents in the mantle, it results to converging of plates, diverging of plates, and transforming of plates. So here you will see how converging happened. Two plates here, continental plates, moves to each other, and the other one shrink, and the other one shrunk. Move up, the other one move down. However, in this case, which is the diverging, when the magma through convection current, you will notice the plates diverge, move towards, move outwardly from each other. However, in the third case, you will see that the movement of the plates move lateral position, oppositely. So these are the result of the movement of crustal plates because of the convection current in the mantle. Ayan. Naririnig nyo ba yung naririnig ko? Nagpapanday kasi ang kapitbahay namin. Gumagawa siguro ng continental plate. So in continuation with the different hypotheses and theories of continental drift, Harry Hess proposed a seafloor spreading hypothesis in which, according to him, crust is created along mid-ocean ridges above regions of upwelling magma from Earth's mantle. An old seafloor crust moves from the elevated mid-ocean ridges to the trenches, and new magma rises and fills fractures along the mid-ocean ridges. The new crust is created, and the old crust descends at the trenches back into the mantle, according to Harry Hess. In this picture, if you will notice, this is a plate, crustal plate, and you will notice here as the magma rises up, it causes divergent boundaries and transform boundaries at the same time, convergent boundaries. In this portion, you will see when the magma rises up at this edge of the plate, the plates move apart. But here, the plates move lateral position. In this case, the other plate sink and the other one rise up. So you will see there the cause of magma as it rise up. It causes movements of plates. It's either diverge, converge, or transform. We all know that Earth is a rocky body. The geosphere is a rocky body. It has a distinct compositional rock layers from the core, outer core, mantle, up to crust. At the lithosphere, which is a physical layer of rock that is composed of Earth's brittle crust and brittle uppermost mantle, called lithosphere mantle, it has 70 to 150 kilometers, but has an average thickness of about 100 kilometers. However, in the asthenosphere, where the lithosphere rests, a physical layer of mantle about 100 to 250 kilometers thick that has plastic or ductile behavior tends to flow rather than fracture. When tectonic plates are however, tectonic plates, these are plates of the lithosphere that rest and move upon the weak asthenosphere. Once the asthenosphere weakens, these tectonic plates at the lithosphere moves. And the zones of abundant earthquakes and volcanic activities are also concentrated along the unstable boundaries. That's why we always found boundaries, or we always found zones of volcanic eruptions and tectonic plates, or I mean an earthquake fault lines in these boundaries. Continents are parts of rigid lithospheric plates that move about relative to one another. Plates form and spread apart along divergent boundaries, such as mid-ocean ridges where magma rises up between plates that's spreading apart. When magma cools to form new rock on the edges of both plates, the plates are destroyed along convergent boundaries, where the edge of one plate may subduct, descend beneath the edge of another plate. The evidences of this plate tectonics hypothesis are just detailed observations, maps, and measurements made by field geologists studying Earth's surface directly. Best modern evidence of lithospheric plate motion is based on Global Positioning System or GPS, a constellation of 24 satellites in orbit above Earth. Satellites transmit their own radio signals that can be detected by fixed or handheld GPS receiver. The most expensive GPS receivers can measure plate motions or movements of specific points over years within fractions of millimeters of accuracy. Three kinds of detected forces produced of these earth forces can be applied to solid mass of rock and cause it to deform or strain by bending or even faulting. The compression, tension, and shear. Compression compacts block of rock and squeeze into less space. Reverse faulting. Tension, which is also known as dilation, pulls a block of rock apart and increase its length. However, shear smears a block of rock from side to side and may eventually tear it apart into two blocks of rock, like this. This is the compression, the tension, the shear. What happens when rock compress is this. When rock is under tension or plates is under tension, this will happen. And when rock is shear, it transforms. When rock is compressed, it converge. When rock is under tension, it converges as well. Because of this movement of tectonic plates cause to move continents. The tectonic plates are movable slabs of rock that make up the Earth. You will notice here that there are zones of volcanoes follows as pattern. And this is caused by the movement of tectonic plates. They occur along the boundaries or edge of tectonic plates, form an outline. So you will see here forming an outline, and these are the volcanic zones. And the dotted one, probably the earthquake zones, and the blue one are the tectonic plates. So through convection current, the Earth's crustal plate moves due to convection current in the asthenosphere of the upper mantle. And this convection current works by heated or heating of magma in the mantle, and the core as well is heated, so it rises towards the crust. And after it rises, magma nears the crust begins to cool, then starts to sink. As a result of this convection current, you will see here how it works. And as a result, continents, small continents are formed. Arthur Holmes state that mantle may experience circular convectional cell like a boiling pot of soap, like what you have seen here, as shown on the arrow here, could carry continents about the earthquake like a giant conveyor belt. And Harry here states that mantle flows in the driving mechanism of plates tectonics, and seismic tomography provides evidence that processes 660 kilometers deep inside the mantle and have a dramatic effect on plate tectonic at the surface. Continue on how rock layers are formed. In this lesson, for lesson B for week 5, you are aimed to describe how layers of stratified rocks are formed, describe the different laws of stratigraphy, determine how geologists correlate rock layers, reflect on human environmental practices that may contribute to the alteration of the Earth's surface, particularly the rock layers, and illustrate an outcrop of rock layers applying the law of stratigraphy. Kanina, movements of plate tectonics, and these movements may cause formation of rock layers. Let's see how rock layers are formed as we go along with these lessons for week number 5. Rock layers may form due to sediments deposited on rock or some forces that act on it which cause its deformation. So what we all know probably is just when magma cools down, it becomes an igneous rock, and this igneous rock might undergo weathering, and this weathered product might cemented in a certain location or area, and it formed to sedimentary rock, and this sedimentary rock might undergo metamorphism when this rock will be buried beneath the earth, and this can form into metamorphic rock. Probably that's what we all know. But according to studies, rock has layers. And this was stated by James Hutton on his principles of uniformitarianism, which according to him, the current geologic processes such as volcanism, erosion, weathering are the same processes that were at work in the past, which cause layers of rocks to have. Speaking of stratigraphy, it is a branch of geology which deals with the description, correlation, and interpretation of stratified sediments and stratified rocks on and within the earth. It is also the study of rock layers, stratigraphy. Take note for that. So may layers pala yung rocks. At yung pag-aaral po doon ay tinatawag na stratigraphy. Stratified rocks, these are the derivatives or derivative rocks or derivatives rock products of sedimentary processes that form layers. Just imagine a Graham cake which have layers. And they believe that rocks has to do with it. And they called it as stratified rocks, the product of sedimentary processes to form these layers. Stratification processes such as bedding, in which the layering that happens in the sedimentary and igneous rock form at the surface of the earth that comes from lava flows or other volcanic activity. Geologists use stratigraphic laws to conduct relationship or to determine the relationship of rocks or the layers of rock. So they use this process, stratigraphic laws, for them to know the relationships of rocks and the layers of rocks. So sana all may relationship. Yung rocks may relationship pala. At may layers din, may level, may label, may layers. Sana all din may layers. In this law of stratigraphic laws, or these stratigraphic laws are identified into six, if I'm not mistaken, or four. The first one is the law of original horizontality. If you will notice here on the side, you have here a huge rock. And these are sediments. According to study, these are sediments deposited in flat layers. And these sediments, which are deposited, if not disturbed, it maintain the original horizontality. Therefore, they called it as the law of original horizontality. But this process will take long period of time, not just a day or seconds or an hour. This will take a long period of time. Just imagine forming these layers of rocks, first, second, third, fourth, fifth, up to the upper most part. It will take time for it to form. However, The law of superposition stated that the largest and heaviest rock layer that settled first at the bottom is the oldest rock layer. So if this is our inner layer, according to this law, this is the largest and the oldest one, the heaviest one as well. And however, the youngest is the upper part, the outer part, that which is they believe and they have proven that this is the youngest rock formation. And however, the law of cross-cutting relationship stated that among the layers of rocks, there was an magma intrudes to that rock layers. And this magma intrudes to these layers of rocks will serve as the youngest one. That's why they called it as the law of cross-cutting relationship. So this is the magma intrudes, which is the youngest one formation, the youngest formation of rock. The law of inclusions stated here that rock mass that contains pieces of rocks called inclusions are younger than the other rock masses. So in a rock formations, there are pieces formed in it, and they believe, as they prove is as they have proved it as well, that these are the younger one. The rock fragments in another rock layers must be existing before being part of the rock. And the last one is the law of faunal succession from the fossil, which was recognized by William Smith, that in a rock, in a certain rock, there are different strata contained on it. This law of faunal succession was first recognized by William Smith. That according to him, different strata contain particular assemblage of fossils by which rocks may be identified and correlated over long distance. So speaking of correlation, we will talk it later. But beforehand, let's talk about the law of unconformities. This law of unconformities, we all know that rock layers are formed without interruptions are conformable. You will see there in this picture at the right side a layer of rock that have been deformed or eroded before another layer is deposited, resulting in rock layer mismatching. So you will see here the different layers has mismatched layers because of the unconformities which have been deformed or eroded before another layer is deposited. So pwedeng mangyari po yun. So there are types of unconformities. The disconformity, which originate from horizontal sedimentary rock layers that is lifted and the top layers eroded, and then new sediments are deposited when they are submerged beneath the fresh water or salt water. like what happened here, you will see at the middle layer, there was deformity. And the other one is the angular unconformity, which originates from horizontally parallel strata of sedimentary rock that are deposited on tilted and eroded layers, produced an angular discordance with underlying horizontal layers. And nonconformity, which originates between sedimentary rock, between metamorphic or igneous rock, when sedimentary rocks lies above and was deposited on the pre-existing and eroded metamorphic or igneous rock. Like what happened on the illustration. Now, how correlations happen on the rock layers or how to correlate? So sabi nga dun sa previous ano po natin, stratigraphy is used to correlate rock layers. Correlation, from the word itself, is a process of showing that rocks or geological events occurring at different locations are of same age. So by correlation, they identify rocks by using this on even from different locations or time. If these rocks have the same age or not. There are two types of correlation. The physical correlation and the fossil correlation. Speaking of physical correlation, they correlate rocks through its color, texture, and types of minerals contained within a stratum or layer. However, when we say fossil correlation, they identify rocks or correlate rocks through fossils with unique characteristics such as lifespan and features of these rocks and estimate the age of rock layers that contains the fossil. There are methods of correlating rocks. Rock types and its characteristics, the index of fossils, and the bedrock. So example of correlation of rock here on the picture stated or shown on the picture by determining the location, the types of minerals on the rock, and matching it. Once it matches, they could have a justification and conclusion that these rocks are correlated at the same time, at the same location, etc., etc. Okay? So much for that. Hopefully, ang mga video lessons na ito for week 5 of Earth and Life Science 11 ay nakatulong po sa ating mga distance learners. Sir Fox was presenting this both for MDL or ODL in a way ay makatulong po sa inyo para magsagot ng inyong mga learning activity sheets. Marami pong salamat sa panunood at kung bago ka pa lang sa channel na ito at nagustuhan mo ang presentation ni Sir Fox, sana huwag mong kalimutang i-subscribe at i-hit ang notification bell all para maging updated ka sa mga susunod pong video lessons. Happy learning, everyone. Marami pong salamat. God bless you.